Welcome to our first flip video. We're going to start Chapter 8, which focuses on quadrilaterals, okay, or any four-sided shape. And today, we're going to be talking about 8.1, which wants us to find angle measures in polygons. Okay. So remember, in this video, tomorrow when you get to class, you need to have the notes that you've taken. In this video, I'm going to include some things, but until I get this password protected, I can't put some of the stuff from the book on. So there's not going to be a whole lot of notes for me to give you this time except for what I give on the video. Along with that, you need to have a summary of what we talked about, and I'm talking like 2 sentences. Sum up what we did in the next 10 minutes. And then you need to have a question. If you have any questions, you need to bring that to class with you tomorrow. Okay? Alright, so the reason that we're talking about polygons first is quadrilaterals are a type of polygon. And before we do anything, I wanted to remind you, and I'm going to put this on the web as well, like next to it in the notes. This is how many sides each kind of polygon has. So if you're a three-sided polygon, you're a triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, and dodecagon. Once you get to 13, let's use 35 for example. If I have a 35-sided polygon, the name of it would be a 35-gon. Okay, it gets pretty easy after 13. Alright, so the first big idea in this section is a theorem, and it's the interior angle of a polygon theorem. And what it says is that the sum, so this is a capital sigma, which means sum. So it says the sum of the interior angles is equal to the number of sides minus 2 times 180. So, for instance, if I have a triangle, like we've been talking about for a good 18 weeks, I have 3 sides, right? So I just pop that in. So I know all of the angles inside a triangle must add up to 180 degrees. Making sense? Remember, at any time, if you need this to slow down, you can push pause, you can rewind, you can do anything you need to do. Okay. So a practice question that goes to that is, what are the interior, or what, let's try that again. What is the sum of the interior angles of an octagon? Okay, and so you would say octagon. Okay, if I use that list, which you are going to need to remember, you will not have that on a test. I know I have an 8-sided figure, so I'll do 8 minus 2 times 180, okay, which comes out to 1,080 degrees, okay? Now, I can also ask that in reverse. I can say, all right, what kind of polygon has the sum of the interior angles equal to 900 degrees. Okay? So basically we know 900 equals n minus 2 times 180. Okay? If I'm solving for n, because I need to know how many sides it has before I can determine which polygon it is, I'm going to divide by 180 first, which gets rid of this guy. Okay, and when I do that, I get 5 equals n minus 2. Well, now I got to get rid of this 2. I'm going to do so by adding. So I get 7 equals n. So what is the name of a 7-sided figure? And that would be a heptagon. So heptagon would be your answer. Okay? There is also a corollary to the theorem, which says quadrilaterals have interior angles that add up to be 360 degrees. Okay? So if we plugged 4 into that formula, we'd get 360. And the corollary just kind of does this duh thing with us. It says, okay, well, quadrilaterals are 360. So using that information, I'm going to draw our little quadrilateral here. And so if I have this situation right here, all right, I need all of this to add up to 180. I'm sorry, 360. Okay, so if I put everything together, I get x plus 288 is equal to 360. And then I would subtract 288 from both sides. Well, I know if this is a quadrilateral, x would have to be 72 degrees. Okay? I'm going to switch to the hover cam for a second because I just want to show you one quick thing. On here, I wanted to show you the exterior angles, what that looks like. Let me get you in a little closer here. Whoa, too close. Okay, so see how if I continue a side of a polygon, I have an exterior angle? Well, Theorem 8.2 says if I add up all these angles, it's always, no matter what kind of polygon it is, going to equal 360 degrees. Okay, so I'm going to zoom this in a little bit and do this. Capture, please place anything. Oop, I didn't do it. Awesome. Try it again. There we go. So if this is our next question, they need to know what x is basically what the question is. Okay. Well, I know if I add everything up, and since it's a polygon, doesn't matter what kind, I know its external angles have to add up to 360. So I'm going to add everything up to equal 360. So if I combine like terms, I get 100, or 4x equals 176, and that should be 360 degrees. Subtract out both sides. 4x equals 184. And then if I divide by 4, I get x is 46. Okay? So if you have, there's one more vocabulary word that I really need to discuss with you, and that is if you're a regular polygon. So if you're a regular polygon, all sides and angles are equal. Okay? So if that happens, and I ask you, if I say you have a dodecagon, okay, so we know that's 12 sides, it's a regular dodecagon, what is the measure of each interior angle? Well, I'm going to do the same thing here. I'm going to do 12 minus 2 times 180. And now I have to do, since I want to know what each angle is and they're all the same, I'm just going to divide them by 12. So I get 1800 divided by 12. And, oops, there's my calculator. 1800 divided by 12 gives me each angle would be 150 degrees. Okay? That pretty much covers it for section 8.1. Remember, tomorrow you're going to bring notes, a summary, and a question. Now remember, we may be adjusting this as we go on, and I'll let you know in each video what I need from that video. Okay? I will see you guys tomorrow.